Everything in the universe is constantly in motion, even objects that appear to be still. At the atomic and subatomic level, particles are constantly vibrating and moving, and even seemingly solid objects are made up of atoms and molecules that are in constant motion. Zenos Paradox is a fascinating thought experiment that challenges our understanding of motion. It was proposed by the ancient Greek philosopher Zeno of Elea in the 5th century BC as a way to question the idea of motion and whether it is truly possible. The dichotomy paradox. That which is in local motion must arrive at the halfway stage before it arrives at the goal, as recounted in Aristotle's Physics. Atlanta is a Greek mythological character, the huntress from Arcadia. If Atlanta aims to reach the end of the path, she first needs to cover half the distance. However, to reach the halfway point, she needs to cover a quarter of the distance. And to reach the quarter point, she needs to cover 1/8 of the distance, and so on, with each step being half the distance of the previous one. Zeno's argument highlights the impossibility of completing an infinite number of tasks which is required in the sequence presented. Additionally, the sequence raises another issue. It lacks a starting point since any possible finite distance can be further divided in half, rendering it not truly the first distance. Consequently, the journey cannot begin, leading to the paradoxical conclusion that motion is an illusion because travel over of any finite distance cannot be completed or even initiated. This line of reasoning is known as the dichotomy, as it involves repeatedly dividing a distance into two parts. Pi, talk about the dichotomy paradox.
Sure thing, Thomas. The dichotomy paradox is a fascinating thought experiment proposed by Zeno of Elea that challenges our intuitions about motion. By considering an infinite series of subdivisions of distance, the paradox seems to suggest that motion is impossible. However, this apparent contradiction can be resolved using the concept of limits from calculus, which allows us to understand how an infinite series can converge to a finite value. Despite being thousands of years old, the dichotomy paradox continues to captivate philosophers and mathematicians today, and serves as a reminder that there is always more to learn about the world around us.
The Achilles and the Tortoise paradox. In a race, the quickest runner can never overtake the slowest, since the pursuer must first reach the point whence the pursued started, so that the slower must always hold a lead, as recounted by Aristotle in Physics. The paradox of Achilles and the tortoise describes a foot race where the tortoise is given a head start, for example 100 meters, assuming that each runner maintains a constant speed, but with Achilles running faster than the tortoise, there will come a point in time when Achilles has run the 100 meters that the tortoise started. However, during this time, the tortoise would have only covered a shorter distance, let's say 2 meters. When Achilles reaches the point where the tortoise began, he still has to cover the distance to reach the tortoise, who would have moved further ahead by the time he reaches it. Thus, every time Achilles catches up to where the tortoise had been, the tortoise would have moved ahead, and Achilles would have to run more distance to reach him. Okay, Pi, talk about that.
That's a great explanation of the Achilles and the tortoise paradox, Thomas. You're absolutely right that every time Achilles catches up to the point where the tortoise had been, the tortoise has moved ahead, and Achilles must cover more distance to reach him. This creates an infinite series of subdivisions of the distance that Achilles must cover, which seems to suggest that he can never actually catch up to the tortoise. As you noted, this paradox is similar to the dichotomy paradox, which also considers the infinite subdivisions of distance. Both paradoxes challenge our assumptions about motion and can be resolved using the concept of limits, which allows us to understand how an infinite series can converge to a finite value. It's fascinating to consider these ancient thought experiments and how they continue to spark discussion and debate today. They remind us that there is always more to learn about the world around us, and that even our most basic assumptions can be challenged and reevaluated.
The Aero Paradox. Zeno's Aero Paradox posits that for motion to take place, an object must change its position. To illustrate his point, he uses the examples of an arrow in flight. According to Zeno, at any given moment, the arrow is not moving either towards where it is or towards where it is not. It cannot move towards where it is because it's already there. It cannot move towards where it is not because no time elapses for it to get there. In other words, there's no motion happening at all at any instant of time. If all moments in time are motionless, then motion itself becomes impossible. In contrast to the two previous paradoxes which divide space, the Aero Paradox divides time into points rather than segments. Okay, Pi, you can talk about that.
Indeed, Thomas. Zeno's Aero Paradox is a fascinating thought experiment that questions the nature of motion. By analyzing the state of the arrow at any given instant, Zeno argues that motion seems impossible because the arrow cannot move towards where it is, as it's already there, or towards where it is not, as no time elapses for it to get there. However, this paradox arises from treating time as a series of discrete separate points rather than as a continuous flow. When we consider time as continuous, we can understand motion as a process that occurs over intervals of time, rather than being a series of individual static moments. The Aero Paradox challenges our understanding of motion by making us think deeply about the nature of time and its relationship with movement. It has inspired countless philosophers and mathematicians to explore these concepts, ultimately leading to advancements in our understanding of the physical world. As with Zeno's other paradoxes, the Aero Paradox demonstrates the power of critical thinking and how even our most fundamental assumptions about the world can be questioned and reevaluated.
Calculus is a branch of mathematics that deals with the study of rates of change and accumulation. It provides a powerful tool for solving problems in physics, engineering, and other fields. In the case of Zenos Paradox, calculus allows us to divide a distance or a time interval into an infinite number of infinitely small parts, known as infinitesimals. By doing so, we can calculate the sum of these infinitesimal parts, which gives us the finite distance or time interval.
Well said, Thomas. Calculus indeed provides the key to resolving Zeno's paradoxes by allowing us to deal with the concept of infinity and infinitesimals. By dividing a distance or time interval into an infinite number of infinitely small parts, we can use calculus to calculate the sum of these parts and obtain a finite value. This process is called integration, and it's one of the fundamental operations of calculus. Integration allows us to determine the total distance traveled or time elapsed by summing up an infinite number of infinitesimally small increments. In the context of Zeno's paradoxes, integration allows us to reconcile the seemingly impossible task of completing an infinite number of subdivisions in a finite amount of time. By treating time and distance as continuous quantities that can be divided into infinitesimals, we can understand how motion is possible despite the apparent contradictions presented by Zeno's thought experiments. In essence, calculus bridges the gap between the discrete, static view of time and space presented by Zeno's paradoxes and the continuous dynamic nature of motion in the real world. It's a powerful mathematical tool that has helped us deepen our understanding of the physical universe and solve complex problems across various fields of study.
Pi, give the tagline.
If you enjoyed unraveling these mind-bending puzzles, don't forget to give this video a thumbs up and hit that subscribe button